All right, let's look at some problems from the Lesson 11 problem set from Module 1. Um, Nothing really changes in Lesson 11 and Lesson 12 from what we've already been doing, what we've already learned how to do. They're just upping the difficulty. By now, almost everything is going to be a mixed number value, a fractional value, or a decimal value. So all these things that we've been doing with whole numbers and integers, now they're just harder because we got to deal with fractions basically. There's 5 of them here. How about I do 3 and I leave you the other 2 to do. So I'll do the odd ones. So the first one says determine the quotient. I'm gonna work down here in this big blank area they give me. Says, so a quotient, that means to divide. Often people say that a quotient is the answer you get after you divide 2 numbers, and that's kind of true, but you could actually call the action of dividing a quotient or taking the quotient in and of itself. So just remember that quotient means divide. So I'm supposed to do, I don't even know why I'm saying all these words. I got the symbol there right for you. So we're gonna do 2 and 4/7 divided by 1 and 3/6. So I'm gonna make a couple of moves here before I even start dividing. First of all, I see that 3/6. Sorry, I have the windows open today because it's so warm and there's like buses and trucks out there. I'll try to speak up so you can hear me. I'm going to change this 3/6. I know that's equivalent to 1/2. So I'm just going to rewrite the problem as 2 and 4/7 divided by 1.5. And I think there are some ways that some people out there actually divide mixed numbers. I honestly don't really know how to do it, and I have a feeling it would be really annoying even if I did. I'd rather just convert everything to an improper fraction and then divide using our process we call keep, change, flip. So the way you change change a mixed number into an improper fraction is by figuring out how many sevenths 2 and 4/7 is worth. And so conceptually you should be thinking, okay, this 2 wholes here, well that's 14/7, right? Because each one whole is 7/7. So there are 14/7 inside just the 2. And then I have 4 additional 7ths up here because the numerator being 4. So that's plus 4/7. So this whole thing right here is going to be equal to 18/7. But there's sort of like a faster process than thinking of it that way. What you can do is just take the number on the bottom of the fraction and multiply it by the whole number, right? Like I could have got this 14 by doing 7 times 2. And then add it to the number on top of the fraction. See, the next thing I did was add the 4, and that got me a total of 18/7. If I did that here, it would be 2 times 1 is 2, plus this additional 1 is 3. So this is going to be 3/2 here. So I'm going to rewrite the problem one more time now as 18/7 divided by, oops, I realize I accidentally wrote 3/7 here when I meant 3/2. Divided by 3/2. And actually I lied, I'm going to rewrite the problem one more time because now we're going to do a keep, change, flip. We keep the first fraction exactly the way it is. We change division to multiplication, and we flip the second fraction. This should really be called multiplying by the multiplicative inverse, but you don't know a lot of those words yet. We'll learn them later in the year. So right now, let's just call it a keep, change, flip. And we're going to do 18/7 times 2/3. I'm running out of space, so I'm going to write my answer down here. 18 times 2 is 36, and 7/3 is 21. And I see that 3 can go into both 36 and 21, so why don't I simplify? I'll divide the top and the bottom of this fraction by 3, and I get 12/7. And you could write that as a mixed number if you like, but I'm just going to leave it as 12/7. All right, so I showed a lot of extra work and a lot of explanation on this one. In the next 2 problems, I'm going to skip a lot of that stuff, and if I need to divide a couple of numbers, I'm just going to go right into that keep, change, flip. So number 3, Mr. Gangle, I don't know, wants to make a shelf with boards that are 1 1/3 of a foot long. So these boards are 1. You know what? Let's yeah, we can leave it as 1 1/3. That's actually a foot and 4 extra inches, but we can leave it as 1 1/3 foot. So this is 1 1/3 feet. And he has an 18-foot board. How many pieces can he cut from the big board? Okay, so this isn't going to be a proper drawing because since I made my board 1 3/3 foot here, 18 feet would be way over there, way off the paper. But essentially the idea is, imagine he's got the rest of this board, and maybe it goes on forever. It's longer over here. And he has this 18-foot board, and he wants to make how many chunks of 1 1/3 can he cut off this 18-foot board. And so that really just comes down to how many times can you fit 1 1/3 into 18. Well, let's write these both as fractions. So 18 can be written as 18 over 1. And 1 1/3, well, that's 3 times 1 is 3,
Attention.
plus 1 is 4.
The 504 being taken place in Mr. Albeck's office is starting now. You are coming to the 504 in Mr. Albeck's office. Please head up here now.
All right, so apparently there's a meeting. So we need to do 18 divided by 4/3. I'm going to rewrite that as keep, change, flip. So it's 18 over 1 times 3 over 4. And let's see here, 3 times 18 is, well, let's do it piece by piece. The 3 times the 8 is 24. And 3 times the 10 is 30. So you add those together and you get 54. 54 over 4. So let's turn this into a mixed number just so we can see our answer better. How many times does 4 go into 54? Well, I know it goes 10 times into 40. So 11 would be 44. 12 would be 48. 13 gets me 52. And I have 2/4 left over. And that's the same as 13 and a half. So what that means is if he had this 18-foot board, let's say this whole thing is 18 feet. I'll label it here as 18 feet. He could cut 13 of these 1 1/3 boards out. Let's see if I can manage to make 13 actually right. I'm going to guesstimate this. I think I should go right about here. 1, 2, I might have made these too big. 3, I'm going to make them a little smaller. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then this one right here would not be enough for another 1 1/3. If each one of these is 1 1/3 feet, this last one here would only be half of that, which is 2/3 of a foot. You'd have this awkward 2/3 foot thing left over at the end. So this is your answer right here. This is how many boards you could cut. I guess you could say the answer is just 13 then, because maybe he doesn't care about the half. Like he can make 13 whole pieces, and that last part just throw away, or recycle, or do something else with. All right. Jason eats 10 ounces of candy in 5 days. How many pounds does he eat per day? And it tells you to remember that 16 ounces equals a pound. All right, so in 1 day, he eats 10 ounces. But that's 10 out of 16 ounces that make a pound. So that's 10/16 of a pound. Remember, the abbreviation for pounds is LBS. That's some old Latin stuff, I think it is. Greek or something, I don't know. So he eats 10/16 of a pound every day. No, every 5 days. Sorry. Look, I've got my thing all wrong here. I wrote 1 day. It's actually 5 days. And we're trying to figure out how much he does eat in 1 day. So we need to take this 10/16 and divide it by 5. And that's actually pretty easy. We don't even need to do a keep, change, flip on this one. So I just wrote the 5 as 5 over 1. Remember, I told you if you want to, you can do fraction division as just top divided by top, which in this case is 2, and bottom divided by bottom, which is 16. This is one of the rare cases where it works out really nice and easy to just do it as top divided by top, bottom divided by bottom, and I just noticed that the 5 and the 10 divide really nicely, so I did it. I would have got the same answer if I did a keep, change, flip, but I saw that I didn't have to do that. 2/16 is equal to 1/8. so 1/8 of a pound. Or you could just think of it as 2 ounces because it's 2/16, and each 16th is an ounce. All right, and so it says, how long will it take Jason to eat 1 pound of candy? Well, every day, so this is, I should mark this as pounds per day to let myself know that that's how much he's eating every day. So if he's eating 1/8 of a pound per day, then I think it's pretty clear to see. I don't even think you really need to do a calculation. It would take him, 8 days, because he's eating 1/8 every day. All right. I see that all my work is just all right here, nice and neat at the end of the video. I hope you're not just fast forwarding to this part and pausing it and copying it. I will definitely be looking for that when I check your homework. All right.